first question, oxidation number of oxygen in ozone is. So molecules and free atoms show zero oxidation state. O3 is a molecule which shows zero oxidation state. So correct answer for this question is option D. Looking towards the next question, the oxidation state of sulfur in anions SO3 2-, S2O4 2-, S2O6 2- follows the order. So here the oxidation number is, let's suppose take sulfur as X, 3 oxygen, so -2 into 3, that is -6, overall equals to -2. So X is equals to 6 minus 2, that is 4, or you can say +4. Then for S2O4, so we have 2x minus 4 2s are 8, that is -8, which is equals to -2. So 2x is equals to 8 minus 2. So x is equals to 6 upon 2. Therefore x is equals to +3. And then if I check for S2O6 2-, that is 2x minus 6 into 2, that is -12, equals to -2. So 2x is equals to 12 minus 2, that is 10, and therefore x is equals to +5. Now if I arrange this, the subset lowest is this, then this and this. That means we have the arrangement in the form S2O4 2- ion, then it is SO3 2- ion, and then it is S2O6 2- ion. So looking towards the option, we have this same arrangement in option B. So the correct answer for this question is option B. Looking towards the next question, the oxidation number of hydrogen in LiH is. So we know that since lithium is metal, it is going to have, and it belongs to group 1. So it has a fixed oxidation state +1. So to balance hydrogen, it should be -1. So the correct answer for this question is option B, that is -1. Looking towards the next question, which of the following is not a redox reaction? So a redox reaction is where the change in oxidation number takes place, and a redox reaction is a reaction where the oxidation and reduction reactions are taking place simultaneously. So we are supposed to look for all the options and see if there is change in oxidation number taking place or not. Okay. So here rubidium is in metallic form, so it is 0. Hydrogen +1 and oxygen -2. Okay, so here rubidium, this OH is -1. So to balance this rubidium will become +1, and this hydrogen is 0. So hydrogen is changing from +1 to 0, and rubidium is changing from 0 to +1. That means there is change in oxidation number. Rubidium is undergoing oxidation, hydrogen is undergoing reduction, and thus it is a redox reaction. If you look towards the next option, then Cu is in +2 oxidation state, and this 2I, 1I is -1. Here the copper is in +1 oxidation state, iodine is in -1, and this iodine, which is a elemental form or a diatomic gas form of iodine, it is 0. So copper is changing from copper +2 to copper +1, that is reduction, and iodine is changing from -1 to 0, that is oxidation. That means the reaction is a redox reaction. Next option, H2O2. So here H is +1 and oxygen is -1. Here oxygen is -2 and here oxygen is 0. So it is a disproportionation type of redox reaction where oxygen is undergoing H2O2 say H2O reduction, and H2O2 say oxygen as an oxidation, because from -1 to 0 is an increase in oxidation number. So oxidation, and this -1 to -2 is decrease in oxidation number, so it's reduction. So thus it is a redox reaction. Next option, that is, this is K plus Cn -1. This Cn -1, so 2Cn -2, to balance this Fe +2. Here also we have the same oxidation state, that is K plus 1, Cn minus 1, and here Fe is in plus 2 oxidation state only. So there is no change in any oxidation state, and thus in this reaction, this is not a redox reaction. So correct answer for this question is option D. Moving towards the last question. In acidic medium, equivalent weight of K2Cr2O7. If molecular weight is M, then so K2Cr2O7 dissociates as Cr2O7 2 minus ion and will participate in the reaction in acidic medium like 14H plus 6 electron will going to give you two molecules of Cr plus 3 plus 7 H2 H2O. Now equivalent weight of K2Cr2O7 is equals to molecular weight upon 6. Molecular weight upon 6. Why? Because the 6 electron is lost. So molecular weight of K2Cr2O7 is 294.2, or you can simply write it as an M. Okay, the upon 6, so it is M upon 6. Now looking towards the option, we have M upon 6 in option C, and thus the correct answer for this question is option C.